Alright, this is off the cuff, but here we're talking about superposition, space-time, which makes a dualistic corpuscular time-shared space, particle reunitizing, reality maker of the black hole that we never left. So, let's see what I got here. It's about frame of reference within the space particle. Okay, now about this space particle. Instead of saying universe, I just say space. And the reason why I want to call all of space a space particle is because when you take a large amount of space or a small amount of space, and since space wraps in around itself in this model, if you have no frame of reference in the size of one that's a Planck length, as an example, or one that is the size of our space in our we'll call it a universe, just so you know what I'm talking about. Normally I would call it I would call it the space, all of space, all of our space, basically, is what I'm trying to say. The confusion with calling it a universe in this model is that I don't want, it shouldn't really be universe if it's connected to other things. So since our universe could be our universe could be a black hole that was in another universe, and our black holes could be are connected to ours through gravity. Connected, I mean that by gravity. So that's it. Is that gravity of that black hole is affecting our system. Every black hole that exists is a dual corpuscular time-shared space, and within it, classical physics will operate, because that's going to take a little bit to show, but it's not going to be curved, because it's going to be particle reunitized space inside of the space that's in the black hole. So in our space, it's been ruled as nearly flat, and the reason for that is because all particles are in the center of the black hole, and their point of singularity. When I say point of singularity, I've come to the conclusion that it's not like a diameter of 0, but in a way it still is, because the particle itself has a purposeful diameter of 0, so it's kind of confusing in a way. But the particle itself goes in with a diameter. Once it goes in, we're talking about not an atom, really. We're talking about a constituency particle, which has not been ever seen, but it has been calculated, and I think it's been calculated to a Planck length, so that's what we're going to use. Then we say that the space, that relativity will break down space dice it up into little Planck lengths, and those little Planck lengths are where the smallest constituency particle will form in the first few split-second moments of a black hole. And then after that, inflation and the gases, and then the results of that will be more complex particles like the gas, which we just talked about, which is, when I just mentioned gas, it would be hydrogen first, and then as suns form and more complex structures, and then it would, but the way that the space emerges is interesting, because that's what inflation is all about. So it looks as though the universe develops rather uniformly, rather than early on, and then with earlier universes being out, which In this model, there is no early out. It's all the same age basically, except for there are parts that are older and parts that are younger, but they're all homogeneously mixed together. So if you were in the furthest edge of the universe looking outward, you'd see the same thing as what we're seeing here. And again, it goes back to that no special perspective in the universe. We're not just looking in all directions by chance that the universe is accelerating in all directions. No matter which way you look, that would appear to be happening. If you haven't seen any of the other stuff that I have, then you might not know why, but we'll get to that. But okay, so let's get to something else here. The reunitizing centripetal force of the particle. So when a particle goes into the singularity, it reunitizes. And this creates a different relativity perspective from a relativistic point of view from our space. They're not connected. The event horizon is a line of separation, you might say. So this separation makes it so Einstein's general relativity will work in there because of its space-time inside there. So, and then it just will have all the rules will be different. The dualistic part is where our space-time is set to the time that we're very familiar with, but our superposition time is set at a different rate that we don't even know what it is. We know it's fast. So fast that every cycle there seems to do it all at once, at least according to light or any other fuzzy wave function. The wave function itself says it's happening all the time. That is, of an essence, the two slit experiment where you have a interference pattern that emerges. In the way it's explained is through waves, but and I like the analogy, but I don't think it's accurate. I think it's trajectories rather than waves. The difference is that the two slits create the possibility of either the trajectory of the wave function is the possibility of that wave, which is going through a trajectory, to go through, if the slit is close enough, it could go through either one due to the fact that it is in a trajectory system. And those trajectory systems are going through a certain amount of frames of reference. And those frames are part of those Planck scales we were talking about earlier. And so from the right frame of reference, if we knew enough, you would be seeing a particle that would be in a trajectory from one frame to the other, and one of those sides would be one frame and the other side would be the other frame, and it will either be on one or the other. And the passing through of the particle also causes the opaque material to interact. Has to be a certain size. They never really talk about the sizes and everything, but the size causes an interaction between those particles and the particles that are going through space, and that creates the interaction between the particles, causes the wave of the trajectory that the particle takes. And in other words, the wave that we talk about that's supposed to be like a wave is not in all places at once. From its own point of view, it is actually a very trackable trajectory. And that's what I'm getting at in that. So I think actually this is on page 111, and I've got a bunch of videos that I released, and I was going to try to release one that was like stating the earlier stuff first, but it's proved to be difficult. Let's see. Okay, so a particle is like a spring under pressure. It adjusts, and that means that realities can run at different rates comparatively. Remember, each singularity has two corpuscular intimately connected times, thus called supertime and spacetime. Light speed is common between the two of them, but those speeds are actually different because the light is reunitized. Point of view. So it looks like, conceptually it looks like this to every particle in space-time. Close up, let's see. So you've got this little diagram here. Point of view. So here we have our frames, and there's a particle in the center. But if you're looking out here, it's going to look like this is accelerating. And if it's out here in relationship to this one, it's going to look like it's accelerating. And if as this one goes this direction, it's just going to keep, the space is just going to keep moving, and the particle will never ever find the edge because it's just going to keep wrapping around itself. And that's a trajectory. Redshift. And on the edge it's going to be, close up right there would show that it's redshifted. And every particle in the middle of the time-setting space, every particle is in the middle of the time-setting space, and if it gets pushed, an adjustment occurs with the energy or flow around that particle getting disrupted. And that adjustment is the most, that adjustment is the moment of inertia. In a magnet, you've got your north and your south, and these are invisible. These magnetic forces are invisible to the human eye in space, but in superposition, it is the orbiting particle, or particles. But from here, they are perceived as like a static, and from our point of view, they are static. So magnetic fields are out of phase with this space-time. Every time reality has a dual corpuscular time that has space-time and supertime. Supertime is at a 90 degrees difference from space-time, and interlacing or collision or cooperation or coinciding can all make particles happen. This flow could cause permanent particles manifestation. And I was listening to some of the string theory stuff, and I was thinking these orbitals are much like strings, except they're orbitals, and they would stitch the fabric of the universe together. I shifted. Okay, oops. Particles are an interacting frenzy of two out-of-phase-time spaces. And that is the nature of the unitization of reality formation. Reality, which is a dual corpuscular time set. It's my first drawing here. Kind of crudely done, but it gets the message across of what I'm talking about. It's a conceptual drawing. Our space is a three-dimensional time-shared space, but superposition space or superspace is a fourth-dimensional single particle alone space stacked with all particles isolated on their own frame of reference alone, yet stacked, sharing the same space particle, all stacked on separate frames. That space can move in any direction for it to wrap around the particle in any direction at any time for all particles, yet connected reality forms as a matrix. So you'll see here we've got this is the matrix, this is the This is space. This is how far you can see in space. It's your limit. And that's space actually. And this is the trajectory of, let's see, that's p particles, potential. These are virtual. And and they can rotate, 360. We don't see that part. We don't see. This is implied, but there's evidence because of the. This is very easy to explain. Entanglement is just on two separate frames, and so when you energize and you entangle two particles, and now they start doing this, and then when you pull them apart, they continue to do that no matter how far apart. And so when you pick this one, you're actually removing it from a trajectory that has two entangled trajectories. And so when you measure this one, you're only going to get it on the up. And if it turned the other way, you'd only get it on the down, because now that other element has been removed. And it's spin up, spin down, spin horizontal, there's all different directions and stuff, but to make it simple, I just said up and down. So on this, you've got your matrix, space particle, the max distance we can see, reality overlays from every point of view in space-time. If light's limit distance-wise is equal to the matrix size, then overlap may occur. Distortion would then appear. In other words, if you could see farther than the matrix, you would get an overlap of. You'd look to one side of the universe, you'd see a scramble of what's on the other side. If you looked on the other side, you'd see a scramble of what's on the other side. So it'd be distorted. Black holes out that distance would cause odd distortions. Closed door black holes would seem transparent with lensing effect. Blur and smudge effect can't rule out wrapping around, which is talked about and fits with my model. Most everything is okay with this model, but not an existence based on the human mind. So in other words, we're viewers, but we're not creating it, just because we're viewing it, right? Okay. Not a multiverse, because a multiverse would be the universe. But, okay. Not a multiverse because the, I just explained the possibilities of the up and the down and faster than light travel. It's not faster than light because the secondary dualistic corpuscular time-shared space, the secondary part of that space is running at a different rate as the first at the quantum level. But general relativity works there too under that unitization. We just don't know what it is. If you have read what I wrote previously, you should know, due to limited quantum updates and an open path that may be bigger than the update process using it goes where it needs to be, creating variations that would never be duplicated because the path is infinite. So in other words, if a particle is a singularity and if it can pass through the Planck length in any point, then your body, everything that's made is going to be completely unique, and it's going to be kind of an amazing thing that so there's not going to be a duplicate use somewhere. It's just not going to happen. But if on the other hand, if it's discrete and it goes through at the exact same point, then then you could believe that if you wanted to. But now that you know how a black hole operates, that a black hole is a dualistic corpuscular time-shared space particle reunitizing reality maker, You don't need that, because it explains what's really happening. Then you can decide to go where to go from there. Actually, so like once this, if this catches on and it fits as good as I think it does, if other people believe it and they accept it, which I think they should, because it explains a lot of stuff. Then I would say that I'm not, nobody's an expert in every field. I just am a hobbyist person with, in the sciences and stuff. But so I kind of have this idea that science never really says that there's more to learn. They always say, well, this is the way it is today, and then they'll say so and so discovered. They may have discovered it, but it was already happening. So it's like, well, today this is this way. And I have heard some scientists do hint about this, but we can say for today we believe this. Tomorrow it might change. Usually you don't hear that so much, or you don't hear it very loud. So we operate on a present truth. It changes, and it's almost as if a veil is lifted and we can see a little deeper. But then it always seems like there's just going to be another veil to lift. But with that said, I'm saying that with what I'm revealing, if you accept that, then I would say that it would be great to give whatever science that you believe, whether it's many worlds can adapt in a way that gives it a more scientific, like it shows an underlying decision process. We're not jumping. Like, one thing that bugged me about many worlds is that the cost. And it's not really, if you have no other way to understand it, it could possibly be something you could say, well, that's just what happened. And but to create something as complex as a human being that is actually slightly different, that's in my theory, the space is captured in the center of the singularity, but it can move around in there, and it doesn't care where. The singularity believes you're still captured. So there's a difference between being captured and being a mechanism, and actually being partially mechanical and partially with a mind that can do whatever it wants. You can walk over there, you can walk over there. The singularity doesn't care where you are, you're still trapped in its grip. But you're free to move anywhere within the core. So I put here, so you are never to be duplicated ever, period. This is assuming that the particle passing through the Planck length is not discrete or the same size as the Planck length. This existence of you is a halting problem, and that's proof right there, if that's true. A fourth. Oh yeah. Okay. Finally, found the words to say. The middle of the singularity has no acceleration, but a particle out 2/3 from the middle will appear to be accelerating at 2/3 of the speed of light. This is the matrix effect, and it is an illusion, as each point will look like this from any point within there. So some of these are just opinions, and they're not necessarily right. They're just ideas. Some of them are implied correctly through experiment. That has already been done, thankfully. I don't have to do it. I think the Planck size would be a possibility that the smallest two energies could produce the smallest black hole, in which we have one Planck energy and one Planck magnetic, creating one closed-door singularity. This special particle would likely be responsible for the centripetal force that resizes against the near-infinite black hole pressure against it. This particle is likely light. I think of it like two folds of energy. We start with a null space and then somehow us. Let me check the time. Wow, that's already been quite a while. So, I think I'm going to mark this spot. And so it's actually, I got quite a few pages written. I was listening to a lot of science. Special thanks out to many scientists. I think I'll add that list later. It's going to be a lot of them. And so again, one cool thing is that the moment of inertia is a trajectory. When you push on something, it's captured in the center of the black hole. From the black hole's point of view, it's captured. From the particle's point of view, the particle is oblivious, believes it's just it's just going on its little path, and you know, with the two that create any type of permanent particle, persistent particle, and the black hole itself, or the space, which I call the space particle, but the whole of space, the space particle, and plus the Planck length of it, a particle, because it seems as though we gain an independence inside the space particle. So degrees of freedom creates a matrix you can move around in and still be have the ability to be trapped, have all gravity canceled due to every point in this part in the space to be the center. And since that happens from our point of view instantaneously, it cancels out gravity, except for the weak force. And the weak force of gravity leaks through at the Planck scale and forms gravity. This cancellation, so when you jump on a planet, and to prove my model, you're jumping on a planet and you're falling to the center of the singularity. If you're jumping on the moon, you're still falling to the center of the singularity. If you're jumping on way far away, even if you're just floating through space where there's no gravity, like the James Webb Telescope, you're in the center of the singularity. When you have one bigger body and one smaller body, the bigger body is going to, through the gravitational mutual attraction, because both are saying I'm in the center and I'm in the center as an argument, the bigger one wins. And then they accumulate their forces, and if it becomes enough, it creates a singularity. Yep, not much time left now. So, again, we're in a dualistic corpuscular time-shared space. The Big Bang was a singularity that we never left. And this reality is the white hole of our existence. Those lines should interest you. You should say, hey, wait a minute, that made sense. I hope you do. See you next time.